Hi all, good morning. Okay, let me share my screen. Please let me know if you are able to see my screen. Hello. Hello. Am I audible?
Yes, I can hear you.
Okay.
Yeah, I can hear you.
Okay, thanks for performing. Okay. So carrying forward from requesting everybody to be on mute when not speaking, right? So okay, let's move ahead. So carrying forward from yesterday itself, but in a very detailed manner, right? Yesterday was just an overview, like what all things will be will study or will go through in Tableau, right? So considering this as a day one, uh, we'll start in that way, okay? So when you open Tableau, right, the first thing you see that you will see a lot of data connectors, right? Now, okay, and you see that the recent open workbooks, right? You can directly open it, or you can connect to a database, to a server, or to a file, and start working on this, right? Correct. Now, to start with, we will anyhow we'll connect with servers and CSVs as well. But let's start with going through save data sources. Okay. Okay. Save data sources. Now, when in Tableau, three data sources are almost are saved. I mean, which comes as inbuilt is sample superstore, model indicators, and intermediate hiring training. Okay. So let's just go to a text file. Like I'm connecting it to, or rather, let me go to SSMS. Okay, SQL Server Management Studio. Okay, till it is opening. Anybody has any questions from yesterday? Any questions like what is live, what is extract, what are the use cases, etc. Anybody?
No question.
Okay, okay. So in that case, in that case, can you give me an example of wait, let me just hide this now. Connect to a server, take the server name. How we are going to connect to server? We'll go take, since this is SQL server, we'll open this. We already have the copied server name. So we'll paste it here and then just set sign in, right? Similarly, then it will ask for databases, like which databases you want to connect, right? So let's go to master and we can choose any as of now here, right? So since the data source is one, let's go to sales itself. Okay, right? Sales itself. Now we have connected to a server. This is sales, right? Okay. In the meantime, if nobody has any questions, I will. I'll just go ahead and ask you. Can anybody tell me what is live? Which one is efficient, live or extract? So let me tell you this: these questions, right? These questions were there in TDS exam. TDS is with Tableau Desktop Specialist exam, which is the preliminary exam. Okay, so a lot of things will come like this. Okay, so what is live and or extract, or which one is efficient? Anybody?
In terms of performance, extract is better. In terms of certain functionality, we may have to use live.
Can you please repeat? I'm sorry.
Yeah, in terms of performance, extract is better, definitely. But in terms of functionality, sometimes we have to use live, depending on what the scenarios. But if it is about performance, then of course, extract is better.
Okay, okay. I mean, it's you're right, but it depends. Anybody else? Anybody else? Then I'll answer this.
To me, extract is better than live connection when the data is small and medium. But when you're dealing with database and that deals with kind of real-time data per se, I think we'll go with live connection.
Okay. Any other thoughts? Any other thoughts? Anybody? So, see, for live or extract, right? There is no clear-cut answer. Okay? Let me say this. Okay, there is no clear-cut answer. Rather than this might feel contradictory to you, but at a higher level, right? At a higher level, without any context, we would say that okay, extract is fast, but there we are assuming that the data set is very huge, okay, and we are doing only historical analysis, okay. So first thing is it depends upon use case. If you have smaller data source, right, and you can use any, you are free to use any connection, you can go to live also. Small data source like this one, it hardly has, let's say it hardly has how many for a date, only Q1 data, only Q1, that too only of 2 months, okay. So here the life will also suffice, and there is no need to extract, since it's very small amount of data, and it can even process faster. But let's say you have too much of data. Let's say I'm talking about um billions of rows, right? Like mostly in financial systems and retail systems, right? If you have too much volume, then the same thing you cannot achieve through life. Okay, right? There also comes two conditions. Like live, if let's say you have live feeds coming, let's say there is an app, uh, you know one second. Let's say there is an app, okay, and this is the data store, and this is the API. Through APIs we are bringing the data into the data source, and then that are directly we are feeding into Tableau. There will be latency, but there will be not much latency, right? This is app data. This is the DB Tableau. Okay. Now the use case, it primarily depends upon use case. So I want to analyze in real time what's happening in my app. Though the data will be too much, right? But I'll have to use uh, live, real time. Okay, correct. Now again, the scenario changes if I'm saying that perform a historical analysis, then that will be extract. So whenever you are asked this question, right? Like whenever anybody asks you this question, like which one is better. So the first thing that you should say is what is it depends upon the use cases, right? And depends upon the volume. I mean the yeah. I mean depends upon the use cases, but in general, if you have a high data volume, then it's better to go for extract. Okay, so in this way you are covering everything. So you in this way you are showcasing in the interviewer that you know the use cases in which live will be used and extract will be used, and which will be uh, powerful in what scenarios. Okay, so that being said, um, I hope there is no doubt for this now, right?
Yeah,
Any
makes sense.
Okay, thanks for acknowledging. So when we connect here, right, we come to the data pane, right? And remember, when you have SQL, it will come into Snowflake. It will come into another level. We'll see tomorrow also. We'll see tomorrow how Snowflake will be. How to connect to Snowflake. So let's go and deep dive into this. So right now you have live and extract connections. Correct. Now let's go to live only as of now. And okay. So this is the when you entered this, when you just dropped it sales here, right? You have this data source name. You can edit the data source name as per your convenience. Okay, you can give your any name and keep it like that. Then you have sales, correct? And this is the data. What are the data showing available here? Their data types also, correct? Right? And it shows you the field name. right? Physical field, physical table, and remote field name. So there might be a case, right? This table is coming from different table altogether, and the field name is different in the base table, source table, right? And we have aliased it, correct? So both the names will be here, the current name and the remote field name. Okay, you can change also. You can change it here as well. You can uh, rename it here as per your need. Okay, so we'll go through that. Okay, once. But before that, let's go to the sheet. Okay, and clear this out. So, are you able to see this side of screen?
Yes.
Okay. So the first thing is data tab, and when you when you go to the sheet, this will be opened, and this one you see there is a tick mark here, right? There is a check mark here over here. So this check mark says that it is a live connection. Okay, it will be a live connection. Okay. Now this under this data source, we have this table in which we have these fields, right? Now you see that the fields are divided into two parts. Okay, divided into two parts. Okay, fields are divided into two parts. Mainly, you see that there is a color difference also. Uh, are you able to see that? This is important because 2 to 3 questions will come from here itself. So our
Sorry,
target.
sorry, we can't hear. There's a lot of feedback. I don't know if someone is unmuted.
Sorry, I didn't get you.
I mean, I think someone needs to mute their mic because we're not, we're not hearing you.
Okay.
Yeah, it's good now.
Okay, no problem. So under the table, right, you have these fields, right, and it is divided into two, correct? You see the color, there is a color difference of this is blue in blue, right, and this is in green, correct? So what does this mean is, so remember we have in SQL also we have two things. We have a dimension field table and a fact table, right? Correct. So similarly here we have two things, dimensions and measures. Okay, dimensions and measures. Let me see my. Okay, no problem. I will now open a new sheet. Let's see. Okay, so there are two things, dimensions and measures. Okay, okay, this, so the blue pill is called as dimension. Okay, and the green pill is basically measures. Okay, or to go further down, the blue pill is a discrete field. Okay, discrete field. So let me give you like this. Okay, there are two things, discrete field and there is continuous field. Okay, so we understand discrete and continuous, right? Discrete is like just example, discrete values are 1, 2, 3, 4, which are not in a continuous format, right? So the continuous field will be, let's say, time, right? The timestamp thing. If you have a data in let's say the stock data, right? It will be a
Uh,
continuous, right? So
is it
every
is it is it possible to take a real time one table or kind of thing and can show us like let's suppose you have a customer table or order table or any table, take like what is discretionary field and what is continuous field.
yeah, we will go through that itself. That's why I have pulled this example also. We will go through
Okay.
that, but before that, before jumping to this, right, you need to understand few things.
Oh, okay.
We will go through that itself. See, my way of teaching is only practicality, direct to the things, right? But there will be
Mm.
few things that you need to understand. It's not that directly you can do and explore things.
Oh, okay.
Okay, okay, no problem. So once we understand what is discrete and continuous, so discrete is what, one, two, three, four, five values, right? And continuous is like 1, 1.1, 1.2, 1. Like you have a streak of continuous values, right? So that will be represented in a different format in Tableau. So when I, let's say, when I pull order date, right, it is discrete as of now. Let's say only 2021, and it comes in blue pill. Okay, so blue pill is for discrete, and when I pull sales count, right, this is for continuous. Okay, okay, you will see that even the representation of discrete and continuous is different, right? So discrete fields or discrete dimension. So this is discrete and this is continuous. Discrete will give you a header, okay, and continuous field will give you axis. This is very important point because this the two questions here itself in tedious exam they will ask like what is the color, how do you differentiate a discrete value field and a continuous field, right? On the basis of two things, one on the basis of color and the second on the basis of whether the field is creating an axis or a header. If the field is creating a header, it is a dimension discrete field. If the field is creating an axis, that is continuous. Okay, now once we understand this, there will be discrete dimension and discrete measure. Okay, there can be continuous dimension and continuous measure. Okay, okay, so I'm talking I'm just giving you the categorization and it's confusing. Okay, but it will be easy to understand the way just focus and just grasp what I'm trying to convey. Okay, so you have two types of field, discrete and continuous. In discrete you have discrete dimension and discrete measure. In continuous field you have continuous dimension and continuous measure, right? Dimension will give you headers and this, and continuous will give you axis. Any questions? Okay, no problem. Okay, so this is you know uh, discrete, right? Now, just now I was saying how to convert it into since time can be discrete and can be a continuous also, right? Are you all agree with this statement? I mean, guys, see, if you are not interacting, then it will be just a monologue, and then later point you say that I'm not enjoying. So okay, no problem. So if I want to convert it into a discrete into measure, right, into a continuous field, I can convert it into a continuous field as well. If just if I just go here and convert to continuous. Okay. So once I convert it, you see that the color changed. And now if I pull in another sheet, let's say, right, it will give me axis. It's not giving me a header now. It's giving me axis, right? So if similarly, if I pull in other sheet, continuous to, let's say, a continuous thing. I'm sorry, a continuous thing. I change into discrete. Okay, the color changed, and now if I pull it, it will give me a header. Okay, so that this is a very critical difference between uh, dimension and discrete values. Okay, so if no questions, that is very nice, and I'll move ahead. I
Could you
hope
help
you.
understand
Mhm,
the discrete dimensions and facts in the continuous dimension? I understood a little bit of what is discrete and continuous,
mhm.
but not the discrete facts in dimensions or the continuous facts in dimensions.
Where exactly did you not get it? Like I'm trying to
So
understand.
the way I'm relating is continuous are the measures, right, which are in the fact table basically. Um, so how can
Mm-hmm.
continuous have dimensions also? Continuous are usually like, I mean, I'm visualizing continuous as facts.
No, yeah. So that's what I think you got confused here. So I mean, when I said that dimensions are the discrete dimensions and this, right? But
Mhm.
that was just to give you a context. So the higher level thing is there is two things in Tableau: discrete and continuous field. Okay, discrete will
Mhm.
give you headers, continuous will give you access. Okay,
Yeah, yeah.
so that you can build different visualizations. Okay, I'll show you in why we need these two. Now we have in discrete field also, you can create a discrete dimension and discrete measure also. Measure is what? Measure is basically it's like some values, right? Let's say you have sales, and then you have region. Region is dimension, is a region, right?
Mhm. Mhm.
Or date will come into a dimension when you
Mhm.
pull any date, right? Any date in data set, you will see that date is a dimension. Okay, and but what if we want to use that date as a continuous field, right?
That's what you showed. Okay, okay. Yeah, makes sense.
Because
Okay.
for trend analysis, let's say, okay, this thing, okay,
Yeah.
let's say convert to discrete. Okay, I just did that. Now for this, year, oh come on, year, quarter, month, date, right? Remove all this. I just don't want. Now this is there, right? When I do sales count, right? See, I'm not getting any trend data, right? Trend analysis. I want to see the trend. Remember yesterday we saw the trend graph, right?
Yeah.
Now if I want to just if I want to just convert into continuous, see, I'm getting some some graph here, and if I just do bar, I'll get that bar. If I do line, I'll get that line chart. Okay, see the line chart, right? Date of order date and the count of sales, right? But if it is a discrete value, okay, see, I'm getting the graph, but see, the way I'm getting is not good, right? I can, if I do this, it will be this, it will be in a tabular format. If I do in bar, see, I'm not getting the way I want. This is not a good visualization, right? I'm getting here also, I have header, here also I have header, correct? But trend analysis will happen only when you have continuous date, date, timestamp or something like that. So, right? So
Right.
Tableau has given us this functionality to convert any field into any discrete field into dimension, or measure to discrete also, and it can be continuous also. So
Got it.
got it, right? So here you
Yeah.
have three questions that is sure shot that will come in TDS exam. That is, what does how do you differentiate? They will give you true, false, and something like that. So three questions based on that itself they will give. The one question will be based on the headers and axis. One will be discrete. How we can what is discrete field? How do you convert it? What is discrete dimension and what is discrete measures? Like these kind of questions. I think we are already gone through that, right? So I hope it is clear now. Okay.
Yeah, it is clear. Thank you.
All right. So one second. Is it clear to everybody? I'm not sure if this is the correct name, but Han, did you get what you were seeking for?
Yes, that's correct. Yeah, I got it.
Okay. Okay. So okay. Now, okay, let's go to. So let's go and create some visualization based on some different data sources. So I'll go to the data source. So whatever data source you want to change, right? You have to come to this tab and then change anything, right? You have to come to this. You can rather change from here also. You can go to data, new data source. You can add, or you can edit data source. You can refresh. You can duplicate. You can make an extract. You can pretty much do everything here. But it will be good if you come to this pane and then do whatever you want to do, right? So uh, I want to open a new file. See, any questions to how do you connect to SQL Server and these things? No, right? I hope
No
no,
question.
right?
No question.
So in SQL Server, what is happening is, as of now, we have very less data. So I mean, performing any visualizations will be a trickier part. I mean, that will be not be very what do you say, real time or real life example. We will go for Snowflake, but I'll have to create a Snowflake instance. So tomorrow I'll take you through Snowflake, but today let's connect to sample superstore data, okay, or world indicator. Anything is fine. Anything is fine. Or world indicators, because everybody goes to sample superstore, but not this world indicators. Okay, let's go to world indicators. So this data set provides example of, like, or come to data source. Okay, this is what. Okay, this is world indicators migrated. This is the table name, and this is the connection. Okay, and this is what you are getting. How the data looks like. You have here. Just example. Consider is as like select 100 top 100 from migrated data. So you will get this result. Okay. Similarly, you understand what it is here. Now, when we go, let's see some visualizations first of all. Okay. I know everybody is waiting for visualization, but for me, that is a secondary thing because if I understand in and out of Tableau, I'll be able to understand it. But let's go and do this. So let's understand the data set first, right? So if you might have noticed that Tableau gives you data types just beside it. Okay. So let's go to data types in Tableau, and then we'll understand the fields. I mean, parallelly we'll understand the fields, and then we'll create a visualization. You see, you have this ABC. That so ABC is denoted string field is denoted ABC in Tableau. Okay. So these are the string fields and our dimension or discrete dimension. Okay. Now this hash symbol is basically a measure, a fact. Okay. And this is a continuous field. Okay. Again, the lending interest is a continuous measure, and it is in the integer data set. Okay. Similarly, this symbol also symbolizes the same thing. Okay. This is also same. Okay. Now this country and region, right? So remember yesterday we were seeing the map. So map is based on latitude and longitude data, right? So this globe symbol provides the latitude and longitude. If you see here, latitude and longitude, that will show us that by using this two fields, we can create a map visualization. Okay. So this is the third data type. Now the fourth one is this calendar. Okay. Which says a date field. Okay. Which is a date field over here. Okay. Now, can you tell me what is the difference between this equals to hash and hash? Any guesses? Okay. So this says that equals to hash is a derived field, right? You understand the main field and the derived field. Let's say sales is a derived field, price is a derived field, but sales into price will be revenue. Sorry, sales is the main field, price is the main field, sales into price is the derived field, right? So like that, number of records, they have calculated it. If you right click here, edit, you'll see the formula. So it's just given one. Okay, you could have given any formula here. So you have bunch of formulas, categories, like you have string, number, date, type conversion, logical, aggregate, user, tables, calculation, etc. Okay, you can give like count of, let's say, population. Okay, population 0 to 14. So this is like a derived formula. Okay, I'm counting population here and there, right? So let's not just make a change as of now here. Okay, and apply.
Are these fields that are not in the original source but created within Tableau?
Exactly. That's why it is derived. I can
Okay.
create any field, right? Let's say I want to CO2 emissions, right? But I do not have, I'm just taking an example. So CO2 emission rate, let's say. I'm not sure about the formula, but let's just for the purpose of showcasing, I'm doing it. So CO2 emission rate, okay? So let's say you will take CO2 emissions divided by, let's say, 100, 1,000. Okay, correct. Now, the moment you do it, and what was the name that we gave? CO2 per emission rate. You see, equals to this. So this is a derived field which we are calculating using the base fields which were there available in the data set. Okay, and you can pull in here into this also. Let's do this. I mean, this is the rate. This is the value. Okay. So don't just be overwhelmed by this, but you understand what is derived field and what is the field in the table.
Now, because of the sign of a derived field, how
Hmm.
do we differentiate that with measures?
So if you see, one second, let me see if I can zoom in. I cannot. So if you see here, right? Yeah, I can. Okay, magnetite. Okay. Um, right. Hold on. Come on. Come on. Okay. You see equals to hash, and this is hash. So see a generated field that counts the number of records in the magnetic table. That is the description that you're getting. So equals to hash, right? See, it's a hash. Here, this is the available field in the base table. In the table itself, it was available. Equals to hash is we have calculated it. The other way to understand is the first way is equals to by default. The other way is if you click here, you will not see edit option here. You cannot edit a base field which is coming from the table, but you can very well edit a derived field. See, right? This is the formula. So let me, I think you all are getting confused. So let me take an example like this. Okay, I'll go the SQL route. So let's say you have a master table, okay, wherein you have customer, sales, price. Okay, these are the tables. Now you're doing select star from master table. Okay, what will be the output? So one, two, one. Okay, two, and two. Okay, what will be the output? The output will be the same table, right? The output will be the same table, correct? So far, so good. You're with me.
Yes.
Now, if I change the query, let's say select customer, sales, price, comma, sales into multiply by price, okay, and give as revenue, okay, from master. Okay, now what will be the output? It will have the same fields plus a revenue field, which will be 2 plus 2 here and 2 here, okay? Right? So this is a derived field, right? This was not available in Tableau or in database. This we have calculated. Similarly, this one we have calculated, and this is already there. Okay. Any confusion so far?
It's fine. No.
Right. Now let's see. Since we understand here, and this example has only these four fields. The data types I am not giving you just a theoretical as of now. I'll be when we will see different data source, I'll tell you what all data types are there. Okay. So as of now, you're clear till now, right? Now let's go and
Yes.
see. I want to use case, right? Use case by use case. Okay. This will be a line chart. Okay. But my use case is, so you can edit it like Excel. You can edit it, right? You in Excel sheets, you can give whatever name you can do, and here you can double click on this, and you see as of now, whatever sheet name will be there, it will be available here, right? But I don't want sheet name. I want to write a use case here. Use case is perform a trend analysis. Okay, perform a trend analysis of CO2 emission over time. Okay, so this is I mean, I shouldn't have written this. I was supposed to give a, I mean, I could have asked a question to understand whether, okay, no problem. So the use case is perform a trend analysis of CO2 emission over time. Did you get this correctly? You understand? You understand the use case?
Yes.
Okay. Now, in your mind, right? What you are thinking? You will require what all things from these fields? What you will require? You will require a time field, right? And a CO2 field, which will give you other data, right? Now, when you go to
Yes.
your CO2 emissions, yeah, right. You have CO2 emissions, right? And you
Yes.
have year, right? Now let's pull year anywhere. Let's just put anywhere randomly. Okay, and CO2 emissions anywhere. Let's say here itself we are putting it. But you're seeing, I just want to, you have year, every year, how much CO2 is emitted, okay, over time. Okay. Now, if I just convert into discrete, so continuous is giving me headers and it is giving me some bar graph, okay. But if I convert into discrete, it will give me a tabular format. So what it is saying is in 2000, year 2000, we emitted this much of CO2 and so forth. And it is increasing year by year. Okay. Now you see this is discrete value. Year is discrete, right? Timestamp you can say that it is continuous, but year is discrete. Now this is called as data table. What is called as? This is called as data uh, table. Okay. This is also one kind of the way you can visualize, which is not very good, because if you want to visualize like this only, you could have chosen Excel itself. Why you have chosen Tableau? But since it's there, I'm just telling you. Okay. So this data table is giving me year-wise CO2 emission. Okay. Now we understand that trend analysis is not something we can do in a tabular format. Okay. So trend analysis should always be done in, I'm going to, I'll go here, right click and duplicate. Okay. Because I don't want to pull in again the same fields. I mean, I can go here and pull in the same fields like year and CO2 emission. Okay. Right. But I want to have the, and the second thing that I can do is I can go in here, right click and duplicate. And then I can change the number as trend analysis.
Very quick question. When we convert CO2 emissions to discrete, it is performing an aggregation on it. Is it for every year?
Exactly. See, that's what you see. It gives you a range. It will also give you the aggregated value only, right? But in 2000, it says, we have done 20 million of CO2 emissions. Okay. So aggregation by default is sum. when you that's a very good question. I was thinking now nobody's catching it, but somehow you notice it. So that's very nice. So see, CO2 emission, when you do it right, by default it is coming as sum. That are you able to see? It's coming as sum. Okay.
Yeah.
So it is summing all of it. When we just give you discrete, it is like total CO2 emission. This is total CO2 emission. Similarly, now you will say that why only sum? I don't want to do sum. I want to do anything, something else. I want to take average. So you just click on here, you go to measure, and you take the average. So what it will do is by default Tableau takes sum. I mean, if it is set to sum, but it depends what you have set, right? So initially here it is set as sum, so it will take a sum. But if I change to average and I bring anything else, energy uses. So energy uses again. If I go here, um, one second. If I bring it here and go, see, it's set as sum. So by default, everything is set on sum. Okay, you can change it as well. I have like here I have taken average CO2, right? You can take median or whatever statistical term things you want to do, right? So for now, let's keep it sum and go to was that? Right here, right? So we want to understand the trend analysis. The trend analysis will be when you go here, hide sorting. The trend analysis will be what? See, in this way, I'll have to make year also to discrete, right? If I make year discrete, sorry, continuous, then I'll be able to do, or you can go and simply click line, okay, and convert into, let's not abuse here. So till now, got it, right? Till now you are sorted.
No, so here, because year is discrete, why
Mhm.
is it not showing it on the x-axis?
One second. What it is not showing in x-axis?
Year, I was hoping that year would come on x-axis and
No, no, no.
CO2 emission on the.
I think you so remember, discrete will give you a header. Continuous will give you access.
Okay.
Discrete will give you a header. Continuous gives you access. See, this is the access, right? So if I just convert it into a continuous, right? See, now both has the access.
Okay.
And you can play around, like, if you want to give x-axis or y-axis. Why it is also not coming is because everything is in rows. Let's go back and convert into discrete, right? If I just put it here, see, you have now you have year in here in this side x-axis and this and y-axis.
Okay.
Correct.
Okay.
And year is as a header and CO2 as a axis. So now you have a trend analysis. This is trend. Okay, this is a trend, and you can just 1 second hide this. You can go to CO2 and label it. Now you will have labels also. So this way you're saying, okay, the trend is it is increasing year by year,
Yeah, makes sense.
right?
Okay.
Right. So this is the line chart also. Okay. Right. Got it. Now in line chart also, right? You will have different types of line chart, correct? So you will have different as in let's say if you have country region, right? Now you want to see trend analysis based on country and region. Okay. I just want to see, let's say I want to see on region basis, what all regions are producing how much of CO2 yearly. Okay, so now the use case is, so this is how I go. Okay, I go by use case by use case. I mean, Tableau you cannot learn theoretically. Use case is uh, region wise analysis, region wise trend analysis of CO2 emission. Okay, one second. Region wise says region wise trend matches of CO2 emission, right? One second, per year, per year. Okay, now what we want, so per year we want a year field. Let's say we want a year field in this way, we want a CO2 emission field in this way, right? Now region field, so we want to uh, dissect or dissect that into by on the basis of region, right? So let's say if I put into a colors, how do I differentiate? If I put into colors, right? Now I'm getting, okay, before that, how many regions are there? You want to take this, right? Okay, these are the regions are there. Now CO2 emissions, these are the CO2 emissions, right? Now year wise, year will be, let's say if I put year, it's here itself. Okay, so this you are able to understand per year what is the CO2 emission for each region. Okay, so this is the value. Okay, now what we are doing is, in the line chart, in this chart trend analysis, what we are doing is we are doing taking year and CO2 emissions, and on the basis of region, when given on color, it will highlight each region in different color and give the values. Just click on this and it will give you the values, the trend analysis for each region. Okay, you're getting on the point.
Yeah.
Yeah.
Okay, so by region we are dissecting it. So this is another kind of trend analysis graph, which is this, you see there are two charts here. You can see this in show me also, right? So let's say stacked line chart. I mean, this is not a terminology stack line chart, but I just gave it. Okay, stack bar chart are there, but not line chart. Okay, let's just keep it as of now. Okay, and this is uh, data table. Use cases based on CO2 emission per region per year. Okay, so this when consider it as like very logical and very in a SQL format, right? If you I mean if you have background in SQL, fine. If not, I'll take you to that level and understand. So per year per region, right? So at year level, what all regions are there and what is the value of CO2 per them, right? So these things will be there. So today we saw data table, line chart, stack line chart, and a higher level of you can say data chart, right? Now similarly you can click on this, right? The sort order, and you can sort on basis of region or basis of sales, CO2. Okay. So I think it is already sorted by basis of sales, right? We'll see sort orders also, but just to give you like this, okay? Uh, it is there, correct? Now, no. Okay. Okay, mobile phone uses, we can do that. But so far, so good, right? You are able to understand? You're getting it? Right, guys? You're able to get it, right?
Yeah.
Okay. So we'll end here, and I'll share the Tableau workbook in group. Okay. And you can, I'll give you few, what do you say, use cases, and you can build around it. Okay, you can try it, and you know you can come up with the book. Okay. Or okay, 1 second. So let me go. So the class ends here, but I'll tell you few other things. Tableau public, right? Switch to this tab. Okay, this is the tab. You can sign in here. Tableau public. Okay, 1 second. Let me just get it. Okay, my profile. Okay, I'm already here. Okay, so you can create, web authoring, right? In web authoring, you can use this as a Tableau desktop also with limited facilities. So let's say I take a file. Let's say I take a file, sample superstore, right? I connected the data. Now you see the the aesthetics is similar to Tableau desktop, and then you can visualize here. You can pull in orders. You can go to sheets, right? Okay, it will take some time because it is creating extract. Okay, now you can visualize. Let's say you have category and you have sales. Okay, so in Tableau public also you can visualize, and it is purely free. You need not need to pay anything. Okay, so you all will use Tableau public. I'll give the link as well, Tableau public and these things, right? And perform this one. Perform these things. Practice. Okay. Okay. Is there any questions? And one more thing.
Where can we get the dataset that you're using in the class?
1 second. The data set. So that's what I want people to at least ask questions. So see, the way I have saved this file, right? The way I have saved this file will give you data set also. See, I have saved in TWBX format. So there are multiple format options in Tableau. The two important formats are .twb, which you see that TWB, okay? The other is TWBX, okay? So I have saved in TWBX, and it is a packaged workbook. So it will have both the data and the uh, uh, It will have both the data and the visualization. Okay, let's create extract itself. It will have both the data set also will be embedded inside it, embedded in the memory, and that visualization also it will keep it. But in TWB, right, you cannot keep the data source, but the visualizations will be there, and it will ask you for questions again to sign in again and again. Okay. Okay, I hope that answers your questions. But no problem. I will share the data source also. When you go here, right, you can, that is, yeah, I'll share the data source. So you can, two things, go through whatever we have done today, practice in Tableau Public. I'll give you some use case, right, and I'll give you the data set. Okay. Okay, fine.
All right. Yeah, thank you.
Yeah, and one of the most important thing is I wanted to tell you all that you have to practice every day, otherwise you will be lost. You will be lost. Okay, it might seem easy, but trust me, when you go in a real execution, it won't be that much, that tough, that easy. But if you practice, it will be very smooth. Okay. Okay, then I'll just share the notebook, the workbook, and will and the others things, and right.
Very
One.
quick question.
Uh-huh.
When we select a file as a source, is it always going to be extract only, no live connection for files?
No, we had live 1 second. Let me share. So when we go, we had live initially.
Okay, so it's possible to create live connection. Okay,
It is possible.
curious. Yeah, thank you.
Uh, okay, so I am sharing the notebook now. Okay, I am sharing the Tableau public link. I mean, it's public.tableau. Okay, now the data set, right? Let's go to world indicator data set itself. Okay, I think I mean people can we can drop now. I'll be sharing it. Okay. So thanks guys. Bye bye.
Thank you.